Have you read atomic structure chapter?
Yes, sir.
Okay. So then today we'll go for the new chapter, Mahia. So today we'll go for new chapter. So which one I can start? Means I can start classification of elements. The next upcoming chapter is one. So that is only we can call as a periodic table. Periodic table. Okay. So in this one, already some basics already you are having idea. Okay. So total in periodic table. So we are talking about the present periodic table. So present periodic table also we can call as a modern periodic table. Okay. Who constructed the modern periodic table means here. So Niels Bohr he constructed the modern periodic table. Okay. In modern periodic table, elements are arranged in the increasing order of the atomic numbers. How they arrange the increasing how they arrange the elements in the elements in a periodic table. In modern periodic table, they arrange in the increasing order of their atomic masses or the increasing order of their atomic numbers. Already knows the elements now. You know,
Their atomic number.
based on atomic numbers. If you see the modern periodic table means total we are having 18 groups and 7 periods. Okay, total how many periods and how many groups are there means here we have a 7 periods and 18 groups are there. Okay, so actually that is a modern periodic table. Before that one, some classification also it is there. Different scientists were they had given us a different classification. Different scientists were they had given different classification for the periodic table. Okay, so all they log in. How many members they log in here? So 3 members only, 2 members only. Na? Okay, let's see it out, my cat. Yeah, so actually, if you see periodic table means until today, total how many elements were there for us means here? Total 118 elements were there. Total how many elements were there for us here? 118 elements are there. How many elements are there? 118 elements. Okay. In this one, up to atomic number 92 are called as a naturally occurring elements. Naturally occurring elements. Naturally occurring elements. After the atomic number 92. Okay, after the atomic number 92. So 92 means that means 93 to 118 elements. So what are the elements are there? All those are we can call as a transuranic elements. Transuranic elements. Okay, so transuranic elements, and these also we can call as a synthetic elements. This also we can call as here synthetic elements. This also we can call as here synthetic elements, and these also we can call as a radioactive elements. Radioactive elements. So this also we can call as here radioactive elements. So now you got the clarity, all of you. Okay.
Yes, sir.
So whatever the 118 elements, what is the main importance of the periodic table? Why should we have to study about the elements means here? So because of we want to study about the compounds, the properties of the compounds. If you want to study the properties of the compounds means compulsory, you have to know the properties of the elements only. Na? If you know the properties of the elements means then only it is possible to study of the compounds. So because of while studying the concepts only clearly we already studied here. Okay, so in a compound, the properties of the compound is completely different with respect to the elements which are present in a given compound. Okay, so that's why to want to learn means so different scientists were they had given us a different classification. So different scientists were they had given as a different classification. So what are the different classification they had given means here? First of all, Dobereiner it is there. Okay, so Dobereiner law of triad we can call. Dobereiner law of triad. Okay, so Dobereiner law of triad. Sir, what is mean by the triad means here? Triad is nothing but a group of three elements. Triad is nothing but here a group of three elements. So triad is nothing but a group of three elements. Okay. Now in this one, once you check it out here, sir, what is mean by the Dobereiner? Okay, Dobereiner also we can call. So Dobereiner or Dobereiner here. Okay, so Dobereiner law of triad. According to the Dobereiner, okay, the atomic mass of middle element, atomic mass of middle element is arithmetic mean of other two elements. Okay, arithmetic mean of other two elements. The atomic mass of the middle element is mean of other two elements. Other two elements. The two elements. Sir, what is the example? So which one are the exhibit as a, which one are we can call as a Dobereiner triad and all means here? What are the examples means? So lithium, sodium, potassium is called as a Dobereiner triad. Okay. And another one is chlorine, bromine, iodine is called as a Dobereiner triad. And another one is calcium, strontium, barium. Okay, so calcium, strontium, barium also we can call it. All this set of three elements are we can call as a Dobereiner triad. Okay, now one I'm going to be explain here. So one example I'm going to be explaining. Okay, so according to the definition, what we are telling that the atomic mass of the middle element is mean of other two elements. That means first we can check it out. Atomic mass of the lithium is 7. Atomic mass of the potassium is 39. If you know these two means, from that one we can calculate the sodium atomic mass. Na? Sir, how we can calculate the sodium atomic mass means it is the mean of other two elements. That means 39 plus 7 divided by 2. Okay, so that means we'll get as a 46 divided by 2. 46 divided by 2 means we'll get as atomic mass is equal to 23. Is sodium atomic mass is 23, ma? Is it correct? Sir. Okay, now so this same concept they applicable for so these two set of elements also, but Dobereiner classification is not applicable for all the elements. It is applicable for only few elements. Okay, clear? And which of the set of elements that does not exhibit as a Dobereiner triad? What is the example means here? So here iron, cobalt, nickel. Okay, osmium, iridium, and platinum. Okay, so osmium, iridium, platinum. So these elements are they does not exhibit as a Dobereiner triad. So why they does not follow the Dobereiner triad means because of they are having nearby atomic masses. Okay, they have nearby atomic masses. They have nearby atomic masses. Okay, so that's why this classification is failed. Okay, at the time of Dobereiner classification, we have a very less number of elements. Okay, at the same time, whatever the elements are there, for all the elements, it is not applicable. It is applicable for only few elements. It is applicable only few elements. After that, which scientists they had given the classification means here. Next. Okay, so Decan Courtiers. So Decan Courtiers also he arranged the elements in the increasing order of their atomic masses. But whatever the elements are there at the time, he arranged all elements in a cylindrical manner. So cylindrical manner means he arranged the elements in a vertical manner. If you arrange only vertical manner means chemical property. What about the chemical properties? Actually, some elements are they show as a so similar chemical properties now. Okay, so that's why Decan Courtiers also it is failed. So what is another classification they had given means here? In this one, Newland octaves. Newland octaves. Newland octaves. So what is the next classification means here? Newland octaves. Newland is the scientist name and octaves we are calling. What is meant by the octa? What is meant by the octama? 8 much here. Okay, octa is nothing but here 8. Okay, now in this one, once you check to mark. So whatever the elements, Newland also he arranged the elements in the increasing order of their atomic masses. Newland also he arranged the elements in the increasing order of their atomic masses. Okay, according to the Newland, every eighth element is shows the similar properties with the first one. According to the Newland, every eighth element it shows the similar properties with the first one. So that's why the classification of the Newland is compared with eighth musical note. Okay, so whose classification is compared with the eighth musical note, ma? So Newland Active's classification is compared with eighth musical note. Okay, sir, how we can compare means let us see. First, I'm taking as a second period element. What are the second period elements are there? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. After the fluorine, generally what we get? Neon we will get. But at the time of classification, they didn't find out the noble gases. At the time of classification, they didn't find out the noble gases. So what is the next element you will get? Means next element you will get as a sodium. Okay. After that, magnesium. After that, calcium. Okay. Sorry. After that, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. Next, potassium, calcium. Now, in this means here, lithium, sodium, potassium are they are showing us a similar properties. Now, once you check it out, 1, 2, 3, 4, 5, 6, 7. Again, eighth element is it shows the similar properties with the first one only now. Okay, so that's why Newland octaves are they compared with the eighth musical note. In eighth musical note, how will get as a sa is repeated sa, re, ga, ma, pa, da, ni. Again, next you will get as a sa only na. So, however, the eighth musical note is repeated means, so that's why elements also it is repeated eighth. Every eighth element it shows the similar properties with the first one. Okay, clear? But this classification is applicable up to calcium only. After the calcium, it is not applicable because of the elements are having different atomic masses. Okay, so what are the elements are they having here? High atomic masses. At the same time, we don't have that much of element at the time of classification. Now you got the clarity? And so next, which the scientist has given the next classification means here, Lothar Meyer. Okay, Lothar Meyer. Actually, Lothar Meyer and Mendeleev. First, both are they started the experiments. Okay, so they started to find out the physical and chemical properties. They started to find out the physical and chemical properties. They started to find out the they started to find out the physical and chemical properties. Okay, first they started the some experiment. They find out uh, some physical properties. What are the physical properties they find out means here? They find out melting points, boiling points here, atomic weights, atomic volumes. Okay, atomic volumes also they find out here. Okay, now 1 second. Okay, right now. So first they find out the physical properties of the element. So after that, they had drawn one graph. So Mendeleev is dropped from the middle of the experiment. Okay. Mendeleev, he dropped from the middle of the experiment and he has taken the atomic volume and atomic mass. Atomic masses they had taken on the x-axis atomic volumes they had taken on the y-axis. Then they had drawn the graph. So they had drawn the graph. The graph is like this here. In this one first, lithium, sodium, potassium, lithium, sodium, potassium. Okay. Then better by drawing of the experiment. So this kind of graph you will get actually. Okay. Now, based on this one, he has drawn some of the conclusion. Okay. Sir, what are the conclusion they have drawn means here? All alkali metals are placed at peaks of the curve. Okay. All alkali metals are they placed at peaks of the curve. Sir, what is meant by the alkali metals, which we can call as alkali metals? Any one of you? Which we can call as alkali metals? Samhita, lithium,
One-A group
sodium.
elements.
Yeah, ma, 1A group element. What are the 1A group elements, Samhita ji?
Lithium, sodium, potassium, rubidium, and cesium.
Very good, ma. Lithium, sodium, potassium, rubidium, cesium, and francium. So, lithium, sodium, potassium are present at lithium, sodium, potassium, rubidium. Okay. So, present at peaks of the curve. Present at peaks of the curve. Okay. And what are the alkaline earth metals are there? So, which we can call as alkaline earth metals? Beryllium, magnesium, calcium, and here we can take as a strontium. So alkaline earth metals are they place the descending part of the curve. Okay, so from here to here, that is going to downward direction only now. Whenever it is going into the downward direction, okay, so whenever it is going here, downward direction. Okay, so downward direction, that is only we can call as a descending part of the curve. That is only we can call as here descending part of the curve. Okay, clear? Next, so halogens, which we can call as a halogens, which we can call as a halogens one. Which we can call as a halogens.
Fluorine, chlorine, bromine, iodine.
Fluorine, chlorine, bromine, iodine. So fluorine, chlorine, bromine, iodine are present at ascending part of the curve. This part is called as a ascending part, increasing. That part is called as here increasing ascending part of the curve. Here also fluorine, chlorine, bromine. Okay, chlorine, chlorine, bromine, iodine here. Fluorine, here also chlorine, here also bromine, like that. So, okay, halogens are present at ascending part of the curve. Okay, and so this one wide range part it is there. So this wide range part is called as a broad minima. Okay, so transition elements are placed at broad minima of the curve. Okay, clear? So transition elements are placed at here, broad minima of the curve. So what are the transition elements? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So all these are present at broad minima of the curve. Okay. So all these are the some important concepts. Okay. So after that, okay. So after that, he didn't. So he arranged the elements in the increasing order of their atomic masses. Okay. But this classification also it is very here. Again, Mendeleev he started classifying the elements. So next, which scientist he has given the classification? Mendeleev he classified the elements. So how the Mendeleev he classified the elements at the time of Mendeleev? Total how many elements were there means here? Total 63 elements were there. Okay, at the time of Mendeleev classification, total how many elements were there means here we have a total 63 elements. Okay, and first he took some 63 postal codes. All of you know what is meant by the postal code? You know or you don't know, ma? Everyone.
I don't know, sir.
You don't know what is meant by the postal code. Actually, if you go for any Photoshop, means generally we can call it as a passport size photograph and postcard size photograph. It will be there. So which is little bit bigger than the passport size. Okay, so that we can call it as a postcard size. We can call. Okay, he has taken 63 postal cards and he wrote the names of the 63 elements on the each postal card. And he started doing of the research and he find out the physical and chemical properties of the elements. Okay, after finding of the physical and chemical properties of the elements, after finding of the physical and chemical properties of the elements. Okay, so what are the elements are showing similar properties? Okay, what are the elements are showing similar properties? They placed under one group. Okay, they placed under one group. They placed under one group. Now, let us say I'm going to copy the Mendeleev periodic table now. Okay, let us see. So you didn't get correct image. 1 second, just I want to copy this Mendeleev periodic table. Searching for the correct. Okay. All of you are able to see the image, ma?
Yes, sir.
So I'm having some network problem, that's why it is stuck. It's very slow. Okay. Now, so this is the Mendeleev periodic table. Okay. So total 63 elements were there at the time of Mendeleev periodic table. So what are the elements? It is showing the similar properties that he placed under the one group. Okay, that he placed under the one group. Okay, and so what are the elements? It shows the similar properties they placed under the one group. So what are the 63 elements are there? He arranged in a vertical line. At the same time, he arranged in horizontal column also. Okay, he arranged in here. So vertical line, and at the same time he arranged in a horizontal also, horizontal rows also. Horizontal rows are called as a periods. Horizontal rows are called as a periods. Okay, and vertical columns are we can call as a groups. Okay, vertical columns are we can call as a group. So as per the Mendeleev periodic table, total how many groups were there? Total how many groups were there, ma? So in this one they had given as 8 groups. In this one it had given as 8 groups. But in NCERT textbook, including 0 group, they had given as 9 groups, ma. Okay, how many groups they had given? 9 groups. But at the time of classification, there is no 0 group elements, but they place some gaps here. Okay, and 7 periods are there. Total how many periods are there? 7. Sir, which one we can call as a periods means what? Horizontal rows are called as a period. So 1, 2, 3, 4, 5, 6, 7. Okay, sir, how you are telling that 7 means one group, once you check it out, somewhere in one box only we have a 2 elements. Okay, in one box only we have a 2 elements. What is the example means? Once you check it, potassium and copper. In one box total, how many elements are there? 2 elements are there only now. So one row here. So one row we can consider it as a 1 period. One row elements are we can call it as a 1 period. Like that, somewhere we have a two periods elements are there. So including that one, total how many periods will get as means here? 7 periods. Okay, total how many elements will get as means here? 7 periods. Okay, now, sir, what are the advantages and disadvantages of the Mendeleev periodic table means? First of all, Mendeleev he arranged the elements in the increasing order of their atomic masses. Mendeleev, he arranged the elements in the increasing order of their atomic masses. Okay. Second point. So he corrected some of the elements' atomic weights. He corrected some of the atomic masses of the element. So for which one he corrected means here osmium, iridium, platinum. Osmium, iridium, osmium, iridium, beryllium, indium. Okay, beryllium, indium, osmium, and iridium elements atomic mass is calculated. He calculated. Sir, how we calculate the atomic mass means here? Atomic mass is equal to equivalent weight into valency. Equivalent weight into valency. So by using this formula, he calculated the sum of the elements' atomic weights. Okay, so that is the one advantage. So what is the another advantage means here? He left some gaps. So Mendeleev is having the foresight. All of you are getting my voice or not? First of all,
Yes, sir.
everyone, you are getting my voice, ma?
Yes,
Okay.
sir.
Here, that's why I'm asking here. Okay, so Mendeleev is having some foresight, ma. Mendeleev is having some foresight. Okay, so he didn't find some of the element, but he knows the properties. So that's why he left some of the gaps for that element. Now, if you see the periodic table means somewhere they left some gaps. Some gaps are there. Okay, so he left some of the gaps for the element, but he knows the physical and chemical properties of the element, but he didn't discover that elements. Later they discovered, other scientists what they discovered that element. Okay, for each one, actually he gave some names. What are the names he had given means here? Eka boron. Eka boron. One is Eka silicon. Eka silicon. Another one is Eka aluminium. Eka aluminium. So once you check it out, in this one, so he used to call it as a Eka boron. What is the present name of the Eka boron means we can call it as a scandium. Okay, so what is the Eka silicon? The present name of the Eka silicon is nothing but germanium. Okay, and present name of the Eka aluminium is called as a gallium. For the scandium, germanium, gallium, he left the gaps because of he knows the properties, but he didn't discover element. Okay, so he left some of the gaps. Okay, next. So what are the disadvantages? Disadvantages are demerits. Demerits, ma. So what are the demerits of the Mendeleev periodic table means here? Okay, so what are the demerits means? First of all, he didn't give the exact position of the hydrogen atom. I think so. Until today, no one given as the exact position of the hydrogen in a periodic table. If anyone they had given an exact position in a periodic table, ma, have you seen the exact position of the hydrogen in a periodic table? In modern periodic
No,
table,
sir.
so hydrogen is placed at center. It is placed at center or not? Have you seen the modern periodic table? Okay, so they didn't give the exact position of the hydrogen in a periodic table. Okay, and what is the second point means? Sir, he didn't explain the isotopes. He didn't give the position of the isotopes. What is meant by the isotopes? What is mean by the isotopes, ma'am? What is mean by the